What about DuckDB is so awesome?
If I were to choose a perfect product to build, I would want this language syntax to be kind of at the core of it.
What are your thoughts on Rust?
I think Rust is a cult.
From your perspective, why is Tableau and Power BI insufficient in the current modern, data ecosystem? Okay, hey Ryan, how are you doing?
Pretty good, Hoy. How are you?
I'm doing good. Hey, listen, I wanted to start this out at the top, just getting an idea of who you are and where your background lies and what you've been working on right now.
Yeah, for sure. So I guess I'll start, I'll try to compress it as much as possible, but, I'm a software engineer, programmer at heart. I've been programming since I was, 14 years old. And my last gig that I worked at was an AI startup out of MIT. And we focused on we did topical modeling for, large companies and stuff like that. And one of the things that I worked on a lot was actually the data. So, building the software was one thing, but manipulating the data and getting results, doing analyses and stuff like that, that was a huge component of my job, which actually led me to doing what I'm doing now, which is Coco Alemana, because I could not stand the way it was done. And I did it for 6 years straight. I tried everything under the sun. So yeah, I'm a software engineer at heart. I love products. I love building things. And if something doesn't look right, I try to fix it as best I can.
Awesome. Okay, well, let's talk about Coco Alemana for a minute, if that's okay. I also kind of want to just get your perspective on being a founder, a co-founder in general. What problem does Coco Alemana solve, or is it trying to solve, and what's it been like trying to get that company up off the ground?
Yeah. Well, we're trying to solve the main problem, if I could go super broad, which is basically working with data is extremely difficult. And what I mean this is you usually have something you want out of the data. You want to do an analysis, you want to look for a particular result, you want to do a model, and probably 80% of your time is spent doing the work to do the work, right? So imagine like you have to drive 4 hours to get to your job that you do for 2 hours, right? As an example. It doesn't make any sense. It's totally crazy. And it's one of these things that we have not seen solved in an elegant way like we've seen it in other industries, how other industries solve their problems. And so that's the biggest driving factor for me is like, can I make this process for the end user 10, 20, 50 times faster and more enjoyable so that they can actually get the results that they're looking for, as opposed to going through the rigmarole of, wrangling data or wrangling visualizations or so on and so forth, right? And just in terms of like getting the company off the ground, this is like what I would consider a high hurdle product to build, where maybe not hard, it's not hard, kind of deep tech in a sense where you have to have a lot of components built to a very like a high enough quality bar for people to actually use and adopt it. And that's kind of the biggest problem. And that's why you see like Snowflake and even Mother Duck and some of these other kind of high hurdle products, they take 2 years to get, even out the gate, right? Because there's just so much software to build in order to be able to service the basic needs of your customers and stuff like that. So that would be the biggest challenge, is that it's not like a traditional startup where you can launch a website with a wait list and then do everything in the back room. It doesn't work like that. This is a pure software company. It's not it's much harder to get that off the ground, let's say.
Yeah. So where would you say you are? Like, what stage is Coco Alemana at right now?
Yeah, well, we've launched kind of an initial product to get user feedback and to get people using the product to help us out. And we're really focused on the kind of just exploring a data set, whether that's locally, remotely, being able to query that data set, clean it up, export it and stuff like that. Something akin to like Alteryx or Tableau prep in some capacity, but without all the limitations. Like, we really don't like those products, but we understand there's a need to kind of do that cleanup stage, right? And so that's kind of what we're focused on right now. A little bit of EDA as well, and we're moving towards the visualization category, which we think is going to kind of tie everything together and make it a much more holistic product that multiple different personas can use.
Awesome. Yeah, I'm definitely gonna spend some time talking about visualizations. I really want to get your insights in that. For the tech nerds out there who are maybe going to want to know, what kind of stack are we looking at for Coco Alemana? Like, what are your favorite tools? What's driving this thing?
Yeah, well, I guess I have a very different stack than most. Like by far, I by far have the weirdest stack, I think. From especially in the data industry, it's not that different from if you were to like build a software like a traditional professional in quotes professional software. It's not that different. But we're on pure C++ and Swift. All right, so we're using native
Wow.
technologies that have access to the maximal performance of the machine that they're on. C++ is great because we've been able to build a kind of core execution engine that we can port between systems. So we can port it between Mac OS, Windows, Linux. We can put it on a server, and stuff like that, and it can all be executed there. We don't have to rewrite the code. We're not using Java or any kind of garbage collected language because you have all sorts of limitations on performance there. And Swift is because we're using the Apple native UI. That's super easy for us to build really quality UI very quickly. Apple thinks of everything under the sun, and they're all available to you in APIs. So it really gives us a great foundation to build a really high quality, high performance product from the get-go, right? And that's,
Yeah.
I think something that most people probably haven't interacted with.
Yeah, I mean, I feel like at least, in data, and I know software is different than, data, but Python is king. Python is king, and we're, when we're trying to be really cool, we're trying to touch Rust. What are your thoughts on Rust?
I think Rust is a cult. No, I think in general, it's like anything. Use the right tool for the job, and Rust really has the same performance as C++. It has it has negligible performance differences between Swift as well. Swift is also memory safe. It's not as crazy as Rust, but Swift is also memory safe. A lot of people don't know that. But Rust for me makes the most sense when you're trying to build uncorruptible low-level components like kernel components and system components. As there's not really an additional benefit to build more high-level software, especially UI. That's like totally ridiculous to build UI with Rust because the borrow checker is so aggressive that it gets in your way most of the time, especially with concurrent, kind of operations and stuff like that. It becomes very difficult to kind of work around it. So I like to just say every language for kind of the job it's best made for, right? And I think Rust makes the most sense for system languages, but we could have gone with Rust, I guess, because it has FFI, foreign function interface, so we could interface with C++. But we decided not to because number one, we know C++. My co-founder and I have years of experience working with it. It's fast. It's as old as time, and it's not going anywhere, right? So that's kind of the main reason.
And so that makes total sense from a software perspective, but this is a data product. This is like a platform for EDA, like you said, in visualization. Given that, what are you going to offer to the end user here who's going to use it to build things on it from an interface and programming standpoint?
Yeah, I mean, our main kind of user is going to be the person who is trying to investigate their data and they don't want all of the headache, right? So we have a focus on making any programmatic interaction optional, and that by default. But so whereas you have like other platforms like Tableau and you have Power BI who kind of make it really difficult to do anything with code, right? We want the flexibility of the code when you need it, but we want to build the interface to be so usable that you're just kind of like, I don't really need to do this, right? I don't need to do this in code, right? Maybe you could export it to code or something else, but it's not the primary way you interact with it, right? And a good analogy is like when you go, it's just a very simple analogy, but when you go to like write an email, okay, you go and you have some interface, maybe it's the Apple Mail app, which is kind of atrocious, or you use Google's Gmail, or maybe use Superhuman or one of those other interfaces, but you use an interface as your primary way of doing things, and you hit send. You're not writing a piece of code to structure the headers, to structure the connection with the end server and stuff like that. And so that's kind of the kind of why we think it's so important to have interactive interfaces, the primary way that you interact with the data, as opposed to a more programmatic way. But
Yeah,
we do have, as an example, the extendability to use SQL in its full capacity with visual changes. So they're bidirectionally linked. So that means if you make a change in the interface, it updates kind of like a reference table in SQL that you can reference, and vice versa. So it does give you the flexibility of both worlds.
Cool. So what are you using for the SQL?
So for SQL, we use DuckDB syntax. And we've created basically a subset of DuckDB, which we call Coco SQL. And it's not just for marketing purposes, but it's actually because we take DuckDB's internal syntax inside of the compiler or the kind of abstract syntax tree that DuckDB creates. We then actually transpile the SQL into the SQL of the database you're connected to. So if you're a local file, it just goes to DuckDB and it's all done, right? But if you're connected to Athena or BigQuery or ClickHouse or one of these other ones, we actually translate all the function definitions, the position offsets, the array slicing, the type inference and stuff like that, right? The type coalescence, the null treatment, and we translate that down to get like a semantically identical treatment. So if you write something with this one dialect, you can copy that same code and run it against a different source, even if it has a different dialect, and it just works, right? So if you've heard of SQL Mesh does something very similar, except it has the kind of combinatorics nature of that, where you have every dialect can be converted to every other dialect. And that's very hard to do. And it often requires you to sit down and make manual modifications yourself. In our case, you write Coco SQL and you get the guarantee that what you write is going to get executed basically every time. And it's going to be correct and you don't have to make any modifications. And so that's why we say it's Coco SQL, but really we just took DuckDB syntax and all the great things that DuckDB has and we gave it steroids effectively is what we did. So just to be, open about that.
That's wild. I mean, you're basically saying, hey, you use one syntax like DuckDB syntax, but we're going to guarantee that the end result it gets to is the native version of that SQL to whatever your end result is, and we're sort of compiling it into that or transcribing it into that, I think is what I'm hearing. So, yeah, I think that's a very novel idea, and so that it's really really cool. I'm excited about that. What about DuckDB is so awesome because DuckDB is having such a moment right now. I'm going to be at the Small Data Conference in November to get more hands-on and meet some people. And Mother Duck runs that. But what is it about DuckDB? I think that is driving so much adoption, and it's a little culty almost. I mean, there's a lot of duckware. Mother Duck's a lot more aggressive with their duckware and everything. But what was achieved with DuckDB that makes it the go-to for these things? Even with what Coco Alemana is saying, we're gonna grab that and use that in ours.
Yeah, I think there's a couple reasons. Okay, so just the main kind of background is why I chose to use DuckDB. I have used every kind of major data processing library out there that you can possibly imagine in one way or another. And they all left me with a bad taste in my mouth afterwards for one reason or another, whether it's syntax, ease of setup, kind of stability. And I'll just give you an example. We started, I built this algorithm to do topical classification of topics at the previous company I worked for. And at the time, it was just kind of like a research project at MIT Sloan Management School. And we ended up using the MIT supercomputer that they share with Harvard. And the allocation we had was the Sloan Engaging Cluster, right? That's what it's called, okay? And so on this cluster, you had to use something called Slurm, which is just weird. It's this super arcane, like old, distributed execution environment. It's super hard to use and it's really poorly documented. And it's a total pain in the butt. And so I had to use that. That was like my first kind of like, baptism by fire, as they say, right? Or whatever. But like I had to use that to get this thing to run. And it was just an endless cycle of errors and crashes and just totally undocumented behavior. And then you have to compete with the people in the physics department who are like, doing crazy stuff and they have all the RAM. So that's a separate issue. But the problem is like, this is horrible and so on and so forth. So then I kind of went through and looked at Hadoop and I looked at pandas and Hadoop was horrible. And using pandas has a limitation. You can only work with whatever you have locally. So even if you get a massive AWS instance, it's still super, super, super slow. Then I went to use Spark, right? And I ended up using Spark because it was kind of that thing that allowed me to do the most with the least amount of headaches, least being relative here, right? As in, like, I still had a lot of headaches, but it was less than the other guys. And Spark really was just a horrible thing. I think Spark should disappear. Unpopular opinion, I hate that thing. I think it should just disappear. So it's the worst thing ever. And I kept looking for new option, kind of new frameworks, new options. There was distributed frameworks called Ray, right? Which I think is by Anyscale, the company Anyscale. Again, same kind of issues that the other ones had. Didn't really like it. Polars came around, and I started to say, okay, this is much, much faster, right, than Pandas, and that's great. Doesn't have the distributed nature, but it's still pretty good. It's still pretty good. And then DuckDB came around, right? And DuckDB blew my mind. I was so pleasantly surprised with every single thing that DuckDB had. The syntax made sense. The inferences on what you were trying to do made so much sense. Like, a lot of times, the SQL syntax is really restrictive. Like, oh, you're missing this thing. You have to have this thing. And you're like, okay, what am I looking for here? And you go over there and you look at it. I had used Athena, which is based on Trino, and Athena has the same problems. Athena has a different problem, which is syntax differences between DML and DDL queries, which is like, what? It's crazy. Like, the way you define a float in like a DML is via float, and the way you define a float in DDL, or whatever the inverse of what I just said was, is real. And so, like, if you don't have those the right way, it's like totally wrong. But DuckDB was one of these things where you could launch it instantaneously. If you could launch Spark locally too, but it takes like 20 seconds to like initialize this JVM environment, which it's like, I'm not going to wait that long. And DuckDB is instantaneous. And I like the fact that I chose C++ as opposed to Java or some more complicated language like Rust, which we were just talking about, because I know C++. I'm very familiar with that. And the thing that made us choose DuckDB was I had used it for a year and a half prior to starting Coco Alemana, and I really loved it. And I was like, I really want this to be available if I were to choose a perfect product to build, I would want this language syntax to be kind of at the core of it. And there's another benefit. There's all sorts of like technical benefits, right? Like it's in C++, which makes it super fast. It's natively multi-threaded, multi-core, and everything like that. But it has a really small binary size. So that means you can include it in like a native application and not have a 400 megabyte downloadable executable, right? That's super important for us. The other thing that's weird, a very arcane detail, is that when you want a native application to start quickly, you have to reduce the number of what are called dynamic library lookups, so dylib lookups. And so if you have a separate library, what ends up happening is that there's a set of, it has to go allocate the memory address space for you. And so it doesn't know that at runtime. And so big packages with big dylibs end up slowing down the launch of your application. And we want Coco Alemana launch in 250 milliseconds or less, right? Like super, super quick. So you can just get right into it. You don't have to wait. Like Tableau takes like 5 minutes to load or whatever. It's crazy. So that's so many different reasons. But I think the main one is it is the most performant, aesthetically pleasing, unified execution engine I've ever worked with, period. End of sentence.
Yeah. And man, I feel like this channel I have on YouTube is starting to become like a DuckDB fanboy channel, but it kind of is the case. I feel bad because if you would say looked at my LinkedIn of like a year and a half ago, I just wouldn't shut up about Polars and everything. And they did come out with Polars Cloud. They're working on that distributed angle. We'll see. They just raised some money too. But you're right. Like, I also thought I was a bit of a SQL purist. Like, I was in BigQuery writing the SQL for BigQuery, and some of the stuff I saw DuckDB, like passing a string in the select, I just thought to myself, I'm just gonna get confused with that. But the minute I started actually doing it, and I was in MotherDuck, which I think is a fantastic product, and I was in MotherDuck, and I can't stand notebook cells, but for some reason it's okay in MotherDuck. I'm cool with it. They have a function in there that you call within where the from would be, to read Iceberg. And I just thought about that. And I just thought, think of the overhead that you just reduced by being able to just do that in a single query. It's incredible actually, and it's mind blowing. And I think the aha moment is just kind of ticking away. A lot of the engineers get it, a lot of the data engineers get it, but I want product managers in data to get it. I want analysts to get it. I want them to see and understand why. And that's kind of what, it's what this channel is trying to do, is just be like, I want to sprinkle everything kind of onto people. So they start saying, well, why is DuckDB so good? Why should we use it? Why should we go with it? Because it's probably a really important decision for your product, for Coco Alemana, I would imagine.
Yeah, and we have like long-term bets on the utility of DuckDB for the next 10 years. We think this is going to really reshape how people interact with data, whether it is in a kind of software engineering perspective, because there's plenty of use cases where just a typical software engineer is going to want to use DuckDB because of it's very much like SQLite, right? And so you can kind of get the performance in local applications. But we think it's just from like a data engineering, data science, and data analytics kind of perspective, it's really great. And in our case, what we found is the APIs, we use the private undocumented C++ API, which you're not even supposed to use. So it's so well written, even in the internals, that I have no problem using it, because I'm like, wow, this is not even like a real this is not like a real API, but it just works so well that I'm just so happy to work with it, right? And it does a lot of other things that I think are so intuitive. That as an example, BigQuery, and I know you're a fan of BigQuery, but BigQuery doesn't do, like, I'll just give you a weird arcane example. Like when we were building this transpiler for BigQuery, one of the things is division, right? When you divide floats, specifically, there's a certain way you're supposed to do that. It's called the IEEE 754 standard for how float division and kind of double division should be done, specifically for dividing with nulls and dividing NaN, negative NaN, and stuff like that. BigQuery has a whole separate set of functions that we had to basically inline to make work. DuckDB just does it out of the gate. It just works, right? And that's one of the things I'm so appreciative of, is that it's a little bit newer. So it's much more modern and caught up to the times, got UTF-8 as standard, all these different things that make you think, wow, why wasn't this done before? Frankly, because of legacy stuff. That's really what it was. These databases were built on top of others. And actually, Hannes has a really great talk that he gave basically about the law, how kind of insane it's been to go from OLTP databases to all this Hadoop and Spark and all this other kind of non-databases back to a database. It's like come full circle, so to speak. And I think it's right. It's basically like we've lost the last decade, 15 years even, based on weird software decisions that were made, and we are paying the consequences now, and now we're slowly coming back to sanity, let's say.
Yeah, I know. I totally agree. It's mind-blowing how we lost track of Occam's razor for like the last 15 years, and suddenly we're just getting back to be like, what if we just make an in-memory database? and from a workload standpoint, most businesses just simply don't need these Hadoops. And I do love BigQuery, but I agree. I think BigQuery, and it's one of the reasons I've been so excited about MotherDuck, is BigQuery is still sort of, it's painted itself into the corner of, Bigtable and Dremel to these large, massive sort of, they pay homage to Hadoop to be these engines that can compute petabytes. No one's got that. No one's got it. No one needs it. And yet DuckDB is here just saying, hey, for most of you, let's rip through this. And the footprint super small. And the way it can, like you said, I can use it for analysis or data science or product. I can do a bunch of stuff. And then you can come all the way to the actual, say, software side of things. Like, this is a viable input as a feature in our software in our stack too. So yeah, I really wanted to get your opinion. I think that's great. One of the other things I wanted to talk to you about was data visualization. And so this is getting more into the experience side, say, of Coco Alemana. And so, and I'd like to kind of maybe touch on design as well, but visualization, you and I have talked before, and I brought up how visualization drives me crazy. I like to use code to create visualizations, and that gives me a customization. I like to do that. But one thing I brought up, I go, if I was using Plotly, and if the makers of Plotly are here and they watch this, they can go in the comments and be like, "Wait, you're completely wrong. It can work." But I tried using Plotly, and the minute I would say want to do a scatter plot, that had to really bring in a lot of data points. I think around 100,000. Those graphs, I can get data. I can go read a Parquet on a S3 or GCS with Arrow and bring it back in milliseconds, and it's there right into a data frame and ready to go. The table, boom, millisecond, just sub-second load, but the page will still take 3 to 5 seconds because I'm waiting for graphs to render and load. I'm waiting for graphs to render. That became this massive bottleneck. And the team I was working with at the time was really trying to figure this out. And we were trying to figure out how could we hack Plotly. We were using Plotly Go. We were trying to get down to the graph objects level. But you kind of had brought up something really novel that Coco Alemana is doing. And so I just wanted to get your opinion on, I think the current state of how we render graphics and your thoughts on how that can be improved to be better.
Yeah, I mean, so there's kind of 2 points that I'll touch on. Like one, as you mentioned, the kind of focus on design, and then the focus on these visualizations. So for us, the design is like the only thing that matters truly. And I mean, we're not designers ourselves, so we're doing our best. And eventually, when we get to a point, we'll be able to hire a full-time designer and everything. But the point is that it should work almost like an appliance, in the sense that it's so easy to just understand what's going on that it's precognitive. You don't have to think about, how am I going to do this? Like, where is this button? How do I do this? Like some weird setting configuration or whatever. It should just kind of work, and it should be very similar to things that other people have already used. So in our case, like, to get on the design component first, we have this idea of a frame, okay? And this frame is not a table, and it's also not like a static frame like you would have in pandas or polars. Rather, it's just this thing called a frame. And what this allows you to do is interact with the data, move columns, reorder them, right? You can filter data like you would in Excel. So very common things that people are familiar with. And you can kind of apply those changes on top of that frame. Now, this frame is a kind of copy on write. So that means that you're actually not modifying the underlying table, but you're modifying only the visualization part that you see, right? So obviously, once you save it, it'll have all those changes. But for the time being, you're only going to see kind of like that kind of preview. And the design around that is basically, with this approach, we can do all sorts of changes really, really quickly. Like if you want to rename a column, or if you want to, as an example, merge multiple values in the value counts, which is very common. So I have this value, I want to merge them together. We can do that in less than 33 milliseconds. Okay, and that is for the full frame render update. And the whole point of that, and actually, when you rename a column in Coco Alemana, the actual update is in the 7 to 10 microsecond update speeds, right? Super, super fast internally. And then you have the render process that has to re-render the thing. The reason why 33 milliseconds is so important is because that is the guideline for what a human being perceives as instantaneous, as real time. And obviously you can't do that with everything, but as much as we possibly can, we want that real-time feedback with everything, because then it feels like the data is not static, but it's live. It's a living thing. You can move it around. It's kind of like when you edit a photo, right? And you get the real-time feedback of applying a certain effects or doing a filter or blurring things out. That all is real time, and we want to have that as much as possible. Which, frankly, you can only do that with C++ and Swift and stuff like that, right? That's one of the main benefits here. But so that's kind of the design aspect. Why we care about the design so much, and then about the visualizations. Kind of our approach to visualizations is we are not going to be able to use the traditional chart libraries that are off the shelf. And we've actually said we're not using them. We're building something entirely from scratch with a library that allows us to do the rendering and basically port it across our different systems. But we're basically at the most fundamental level possible. And when you have something like Plotly that has a bunch of dots, right, it has a bunch of points on the screen, what ends up actually happening is you have all those points on the screen, but then they, like in quotes, they have to go through the CPU and then have to get rendered. And every time the CPU is doing everything, right, which is super, super laggy, especially if you have real-time interactions and stuff like that. And even if you're on WebAssembly, it's still single core capped. So you're not going to have the performance of a multi-threaded operation, even if they decided to write it in C++. But in our case, what we've decided is we're going to do everything on the GPU, right? And so we have the ability to do that because it's a native app. So you download it like you would Tableau. And this is a very intentional decision. This is not something where we're like, we want it in every web browser. The web browsers have way too many restrictions on performance. They have way too many restrictions on usability. There's a million other things I could go on about. But with the GPU, we have the ability to render all the data on the GPU. And something that we haven't got to yet that's actually entirely possible with DuckDB, and really any technology that has this ability, is we're able to, we could theoretically transfer all of the data directly to the GPU, bypassing the CPU with no overhead. So that's really, really strange to hear. But that's because we can use, DuckDB has an internal format called in-out table func or something like that. And if the memory is stored on the CPU, if the memory if the CPU stores something in memory on max, it's all unified. So that means there's no latency transfer to the GPU. Now, we'll have to translate some stuff, of course, to make sure it goes over, but that is one of the biggest bottlenecks, which is going from, let's say, your whole data set that you have in memory, converting it into a stream and pushing it, and then you have to push it back onto the GPU. We could potentially just completely override that. So you have the functionality of being able to put hundreds of thousands, millions of animated points onto a graph or interactive points, then also the kind of latency that it takes to serialize all that data from the CPU into the GPU. And so that's where we're focused, is GPU accelerated graphics from the bottom up, right? And go from there.
That's like, I mean, it's the first time I don't know why it's the first time I'm hearing this, to be honest. I also don't know why I haven't like thought like, why isn't this just being on the GPU? And I think that in a lot of ways it's because, especially data people like myself, we think about the CPU all the time, right? We're thinking about how can we maximize the CPU? We've got multi-threaded options. You know, Rust is doing it, Polars is doing it, DuckDB is doing it. That's the big thing to do. And it's like, yeah, let's leverage the cores. Let's do all that. And it also comes down to always this idea of crunch time, compute time. We always want to reduce the compute. We want to always do that. We always want to get there. And then for whatever reason, like me, I was dealing with this situation where I felt like I was just pushing Plotly to the limit and maxing out, and I really couldn't get any more out of it. And I was thinking to myself, oh, maybe I should save it as a graphic image and then compress it and bring it in if that happens to be the filters that they choose. It's just a completely unrealistic, unscalable thing. But yeah, it should be on the GPU. To your point though, you know, I was leveraging Streamlit, and so that's up in Kubernetes, and that's in that's a web app. But being native like that, it gives you the ability to really get as much out of your system, your local system, as possible to get the best experience in that way.
Yeah, that's our primary focus, right? Is, this is going to be something, what we consider a professional app. So somebody that's going to use this on multiple hours per day on a daily basis. And so you want absolute 100% maximum performance. But with the software that we're building, there is the opportunity to port it to, as an example, embed on the web, right? And there's a great technology that is built in called WebGL, which actually takes advantage of the GPU's renderer. We can do that, right? So we're not like building ourselves, a wall around ourselves, let's say, but rather we're choosing the most kind of low-level technology possible that also allows us to expand and do things on the web if we choose to in the future, right? So we want it to stay as high performance for right now, but we also have the option to make this as a package or something else that somebody can, can use on the web for whatever use case they have.
That's awesome. And,
I think it is a testament to kind of the thought process I feel like I've seen with you and I's conversations prior to this about a lot of care about the downstream experience. So let's talk about that. Let's talk about the downstream experience, and let's call out two big, old elephants in the room, which is Power BI and Tableau. This will be the saucier part of the podcast, but I am an avid. I do not like Tableau. I do not like Power BI. I understand they have incredible market penetration. I don't care. I don't want to work on it. I don't want to use it. I think that they are they're completely beholden to their old architecture, and they just keep trying to hack stuff onto it. And the fact that we have to work around it like an arm tied behind our backs all the time, to me, is holding back that part of the data industry and the data software industry in general. And it is keeping, I think, real innovation from happening, because I think when I see these new tools coming out, I feel like they're just trying to be marginally better than Tableau and Power BI, to be completely honest. They'll throw AI in there. Okay, great. They'll throw agents in there. Great. But in the end, it's sort of a menu diving, experience to make an app, a graph, right? But let alone an application. So let's just talk real quick, from your perspective, why is Tableau and Power BI insufficient in the current modern, data ecosystem?
Sure. Well, I can primarily talk about Tableau, and I'll stay on that as much as possible. I have used Power BI in some circumstances, but I'm not a Windows guy, and I will never be. So that's already. But I've heard really bad things from many people about Power BI. But let me just talk about Tableau, because that's what I know the most. It is the kind of only option for people who want to visualize data who are not technical. And I know this because I've talked to, at this point, hundreds of people about this problem. And they're like, yeah, I use Tableau when I need to. It's not great. They're always like, yeah, it's not great. Like there's like maybe one or five people that are like, yeah, I love Tableau. Cool. Everybody's entitled to their own opinion. But most people are like, I just don't really like it. In my personal opinion, the biggest problem with Tableau is a sales company that has a software application on the side, right? And their whole org is structured around sales. And this is important because it tells you where their focus is. If their focus is on just getting that additional enterprise customer and that additional, 3,000 seat license deal with, one massive company, what is Charles Schwab or, some big bank or something like that, yeah, they're going to focus entirely on that. It shows so much in their software. It's not even funny, because Tableau, I started using Tableau like 7 years ago, and it hasn't gotten better at all. Like it hasn't even like improved incrementally. Like they're just like, we made some fixes here and there. We added some like Einstein AI thing that doesn't make any sense and it's not really helpful. But then I sit there, I'm like, can I add confidence intervals to this chart, please? Can I create like a pie chart? Can I do like the most basic things? Oh, the answer is no. Oh, why? Oh, well, because they're too busy selling the product to other people. All right, well, whatever, right? And so that's the biggest driving factor to why Tableau is just so bad, because it's a sales organization at heart, and then it got bought by Salesforce, which tells you everything you need to know. But then the main thing I have a problem with is that from the user interface perspective, from the experience perspective, Tableau expects your data to be perfect out the gate. You can't have any issues with your data, which is like a fever dream. That will never happen. You're always going to have some issue with your data, especially at small organizations that don't have, an insane amount of money to spend on data engineering and all the capabilities that brings. And so what ends up happening is that you're like, oh, I want to like do this thing in Tableau. Well, it's not in a long format, it's in a wide format, or vice versa. And Tableau doesn't like that. And you're like, all right, now how do I change this? Oh, well, I can use it in Excel. Oh, the file's too big to do that in Excel. Oh, I can use Tableau Prep, which is the worst product in the history of mankind, because it just crashes. It just breaks. It's like they didn't even try to make it work. It just fails on the first time. And then so what you end up doing is going into Pandas or DuckDB, right? Or some other kind of programmatic environment, and you manipulate the data to get it into Tableau. Cool. You've got the data cleaned up. Now you go into Tableau. You start to visualize some things. Well, guess what? If you go outside, first of all, they have a shelf thing, which is like weird. And I've never understood that. I've used a tool for years, and I never understood what that was getting on. But the main problem is that it's so inflexible that if you have like even like a 30th percentile use case, you now can't use Tableau. And so like if it's more than like sometimes it feels like if you have a 50th percentile use case, you can't even use Tableau. Like if you want to do the most basic thing, it's a whole menu dive, like changing the colors is a total pain. You can't round the corners of things easily. Like all sorts of like design related things are just horrific. It's a total just horrible system that feels like it's built in the 2000s, like 2002 or something like that. And the main thing is that what I think they're totally missing the ball on is that when you work with data, specifically when you visualize something, it's not like the final task. It's not like, oh, I have finished my data and now I start to visualize and this is the value that I'm getting out of this. Of course not. It's a cyclical thing. You make a visualization, you find something weird, you go change the underlying data, you come back, do X, Y, Z, right? And then you might create a dashboard that you can publish and show to other people. But Tableau is totally inflexible to any of the cases I just mentioned. And so it's just, oh my goodness, it's horribly designed. It has great market penetration. That's horrible, you know?
I know it is. The thing that really got me really good at Python was trying to find a way to make something better than Tableau. Because I was getting asked as say, we'll use Tableau, and I would start in, and I was just thinking to myself, how could something be so unintuitive? As you know, and then I'd look at people who are good at Tableau, right? And they're just here ripping through stuff, and I'm looking at them, and I'm just like, you know, maybe this is like Perl programmers at this point now. It's like, you know, they know something so well that outside of it, it just doesn't speak in any way, maybe to other languages. It just doesn't move over there, but they're just ripping through it over here. And it will always be probably a legacy system in many, you know, enterprises that you'll need someone who knows how to do Tableau. But you are learning in a vacuum. Whereas I thought to myself, could I somehow get around this? And it was going and finding Plotly and then finding Markdown and LaTeX and being like, I'm just going to make my own things. I'm going to make my own, you know, I'm going to render my own reports and everything. And that's what led me to more of wanting to use, say, the Streamlets of the world, where I was like, I just want to do this myself, because I was so turned off by the unintuitiveness of Tableau. Yet at the same time, it's huge amount of adoption and overwhelming, I guess, just acceptance that that's good. And the whole joke I kind of say is, I'm like, I see all these data engineers on LinkedIn and on Substack, and they're talking about these incredibly huge, complicated infrastructures, and we're sending this through here, and look at all this stuff. And then at the very end of this huge architectural diagram, at the very end, the very edge, all the lines end to BI, and it says Tableau underneath. And I'm just thinking, you do all of this work to cram it into this crappy, unintuitive interface that people then don't even look at. So, you know, there's a product piece there, I think, that overwhelmingly is just sort of ignored, and to the point that you said, where everything's about sales. And I think that's what drives the competitors. They can't be too much different from Tableau, because that will confuse the enterprise, you know, contract that they're trying to get. So they kind of have to give them a similar experience, but saying, oh no, this is better, this is better. And I am not sold that it is better.
Yeah, it almost never is. And I, you know, of the people I talk to who work at larger organizations, the people who I've talked to who work at smaller organizations generally go with they either go with Power BI or they go with Tableau because it's cheap. Like, it's relative, all things considered, it's really cheap, as opposed to paying for Ultrix, which is like $5,000 a year per seat, which is like totally stupid. But the people at these larger organizations, they might have something like Click or Spotfire or, you know, what's the other one? AWS QuickSight, right? Or one of these other ones. And I ask the people who are kind of what I would consider the individual contributors, people actually using the product on a daily basis. I'm like, hey man, like, what do you think about this product? And I'm like, oh, it's horrible. Like, so how did it get approved? And like, because the VP just shoved it down our throats. There was no really like discussion. We just have to use it now. And I think that is, you know, Tableau's biggest advantage is distribution, 100%. There's no product advantage that Tableau has. It's all just market. They've just captured the market really well. They've had a really great sales team, and that's what's made them a huge company. But that's also where the big opportunity is, because if you're able to make a really, 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 really good product and able to solve the distribution issue, man, then, you know, you can totally beat them, right? And I think what you said about the whole like diagrams and having, you know, all these different tools, that's kind of like a symptom of the last 15 years in Silicon Valley, because I think, you know, this might be Paul Graham's fault, maybe not, but from my commenter, but basically it's like, focus on one single thing. And I think that has been taken to the, like, maybe the advice is great, but it's been taken to the extreme where people are like, oh, we're only doing a DAG service. And you're like, or a lineage service, or we're only doing this thing. And I'm like, yeah, but that's not encompassing the whole workflow of somebody. It's like, that's encompassing one tiny thing. It's like the equivalent of getting in your car and saying, all right, well, I got to go get a door. So I got to go find a door vendor that can buy a door from, and then the steering wheel and all this stuff. That's totally dumb. You want like a cohesive kind of all-in-one product that to handle the majority of the use cases, especially from the analytics, data science side.
Absolutely. And it's so funny. We should just blame Paul Graham for it. That's fine. Let's do it. And, the thing there is that is kind of, I think the roosters have come home to rest. Is that how the saying goes? But we now see Fivetran taking on SQL Mesh, Fivetran taking on dbt. They're trying to get an all-in-one system so they can go and compete with everyone. That's what I'm assuming. But you kind of see now the modern data stack, which was really that, go focus on one thing. And it just became a bunch of separate things trying to stitch them all together. And that was us data engineering. We're finding out that that's a huge pain in the ass. There's a ton of overhead. It's really expensive for upkeep, where all we really needed was a nice, small, clean, singular experience. And it should all sort of be in one place. I feel like as well, not to get into data engineering specifically because it's a whole other topic, but I really wanted to stick on product and design because when it comes to these tools like Tableau and Power BI, there's just not much taste put involved. And I think in general, when you look at even the competitors, I'm not going to name any, there's definitely some cool kids on the block, but even still, I look at them and I am thinking their marketing's good, the website's good, the tool itself feels okay, maybe a little better, but where is that Apple level of obsession about design and experience? I don't know if I'm seeing that. And what are your thoughts on that?
Well, yeah, I have some pretty strong opinions on this. I think that this industry as a whole does not attract people who are good at that, because if you were to talk to somebody outside this industry, like data, like reporting, ew, that's boring, is like all get out, right? Like, what is that for? I want to go work at a video editor app, or I want to go work for Pixar, or I want to go work as an animator, right? I have like real design skills. I want to go to these industries that really attract this talent, right? I want to go work on a video game, right? Or something really enthralling, super cool. I want to work for a company that has massive distribution. So my design gets pushed to hundreds of millions of people, right? Think like, maybe Instagram or one of these other apps like Duolingo that have like the kind of core of their, Duolingo specifically, the core of their business is like a really fun, animated, nicely designed experience. You're not going to get those people naturally trying to come into these companies. So I think our strategy is essentially to go out and find people who have nothing to do with this industry. Weird, right? Like totally different approach. My co-founder has nothing to do with the data industry. He's mostly a front end guy. He worked for Streamlit actually several years ago, but didn't end up staying there. I think he's kind of bummed out because they got bought for a whole bunch of money. But like,
not pre-acquisition.
Yeah, right. Yeah, and so, but he, his background comes from video games, right? So you're going to have a whole different perspective on how you architect things, how you design things, if you bring people from different walks of life that are not in your industry. And so our strategy, and please don't take the strategy and steal it from me if anybody else is listening, but basically I want to go to people from Pixar. I want to go to from people who were working at Apple previously, or like the OGs, not like the people who are working now and did this whole liquid glass debacle, right? That's horrible. But the people who used to work at Apple, right? The people who work at Porsche, right? Or the kind of companies that are known for quality products, quality design, and bring the things that my blinders will not allow me to see. And the people in this industry, it's not possible for them to see it because they haven't had the experience of working with people from a different industry. And I think that's where kind of like the opportunity is to get a really good, well-made design, is to bring the problems from your industry and the solutions from others and merge those two. Because then you're going to get such a great mix of people where you have experts in the problem and experts in really building a quality solution, and we're not overfit on the existing solutions within the industry. I think that's extremely important.
I think that's awesome, and it's so desperately needed. And I kind of coincidentally enough, I started my career out testing cell phone video games at Electronic Arts. That's how I started my career, and I was really good at finding bugs in games. That's kind of what led to me being analytical and writing things, and eventually finding my way all the way to data and data science, and then to product management for data. I bring a lot of that back because I was trying to figure out, how can I break this experience? How can I figure out what's wrong with this? And that's actually a skill within product that's really not there, the product mindset. And that's one thing I think I'm real impressed with just the way that, y'all are talking about, Coco Alemana and just the way you think about it is that product mindset. It really is lacking in this area of the stack, of the data stack, and maybe across it, but let alone, trying to build a project from the get-go. There's a lot of discontinuity throughout all the teams involved. But by the time we get to the most important part, which is the experience to the user, after all that work, what you're trying to do is create value with a freaking UI so the sales team can make a decision on something. And that's a pretty profound thought that seems to always miss everybody. So I think it's really good to have that concept of, well, who is good at this? Let's bring them in.
Exactly. Like that has to be the first thing you look at, because like complex technical problems can be solved in a million different ways. And I think there's no shortage of high quality engineers. If you give good engineers good constraints on what to build, they can do amazing things, right? And so the people to find those constraints are, in my opinion, the designers, the product people who think of things holistically, right? Who are up here almost, right? But can kind of helicopter up and down. They can go, I'm at the high level. What does a product look holistically? And then they can say, the spacing on these two buttons is just too small. We need to make the spacing just slightly bigger, right? Those types of things are important. And I think that, design is so important to a good product. And it is industry agnostic. It is, product agnostic, right? Like any product with a really good design is going to get people to come back, right? They're going to go, wow, this is really great. And this is an extension, I think, of the general customer experience as well, right? How does a customer perceive your organization? So if you've ever had really good, customer support as an example, right? That's like something you remember, right? Like you remember, the service was really good. Like if you call Apple and you say, hey, I'm having this problem, they're really good. If you call American Express, they're really good, right? Like they know how to handle you as a customer. And that's, they don't really have that much of a product, right? They have like the little credit card, but that's about it. There's not really like anything outside of the customer experience. And they know that it's so important. And that's really, really the only thing that matters. Because then you get all sorts of positive benefits. Like obviously the product has to work, it has to do the job correctly. It can't just be all about how it looks. But if you get the functionality down, you get the design down, you get a lot of positive kind of word of mouth. And that really does help kind of attract other people, because then they start to recommend it to their friend and their friend of a friend, as opposed to getting sold by a sales executive, let's say.
Yeah, I mean, and huge advice for anyone thinking about making a product right now is, I think you have to be so experience obsessed. You have to really think about it, because more and more in the age of ChatGPT, when there is a screen and we just type in what we want and things happen, the bar has been raised, and there's a lot there that you have to think about. You can't just get away with the same stuff that worked for the last 15 years. I think I kind of want to close it out by kind of asking, as a founder, co-founder, maybe what's the type of, I don't like to say advice. I hate that, because it's like advice. What is advice? Everything's different. But, what is the ambition you have that led you to say, I'm going to try to, get Coco Alemana off the ground, and I'm going to spend, a lot of my time on this, and I'm going to work on this? What is the real driving force there? And for anyone who's thinking about doing this, what would you say they need to definitely have before they go take that first step into that founder type of headspace?
Well, yeah, I think the main thing for me specifically, this might not be the same for everybody, but I do see the most success when this is the case, which is there's a lot of people nowadays, for whatever reason, like if you want to start a company, it's like hip and cool and stuff like that, but it's not fun. Like it's like not fun in the sense that like there's a million other things you have to do that you don't realize, right? And so I think there's, Y Combinator has popularized this, if I can speak correctly. But basically, this whole like idea that you have, right? Like your idea is this, that, and the other. And you have a lot of like younger, people or people who want to do it for the first time. They go, let me go find an idea that I can start to solve, right? And that for me is like, let me go find an idea, as if it's like an assignment to go look and see, what thing I can solve. I don't think that's right, personally, because you have to have like an insane amount of mental fortitude to continue when nothing's working and, it breaks all the time. So you have to be obsessed with the problem you're solving, like obsessed with it. And in my case, this was something I dealt with literally for 6 years straight every day. So this was like, I have to fix this. This is like, I can't just ignore it. It's been punching me in the face for so long. I have to fix this. And so that is the biggest driving force, is something that really bothers you on a level that nothing else bothers you. And there was nothing else in my life or in my work or anything else that bothered me so much like this problem did. And I said, I have a background that is building apps and software, and I know I can kind of pull that over and, make this problem, solve this problem, in my own way, but solve it. And, I think I have a good way of doing that. And I would be stupid not to, effectively. And so I think the main thing is you have to be solving a problem you have dealt with for an extended period of time that causes you disproportional pain, right? So like, yes, traffic is annoying. Everybody hates traffic, but like, is the pain disproportional? Yeah, not really, right? Like everybody deals with it. It's pretty impossible to solve that too. But like, if nothing else in your whole work life or life in general bothers you as much as this thing does, yeah, you should probably fix it. And I think that's the main thing, because you're going to get fatigued. You're going to go, I don't like this anymore. This is boring, and then give up, right? And it's mostly that, right? If you can just not give up and just not die, right? Then you have a shot, right? So just to keep the motivation up, right, is the main thing.
Amazing. Awesome. Yeah. Famously, you're always being told the founder of Uber didn't know anything about taxis. The founder of Airbnb didn't know anything about hospitality. Yeah, I feel like I would want people who have hardcore understandings of the problem set. That's the way I think about it. So I agree with that totally.
Yeah. And even if you don't have the like hardcore understanding, like if you've dealt with the problem enough and you're a victim of the problem enough, let's say, you can learn anything, right? And so obviously it helps a lot when you already have the background. That obviously helps a ton, but just being annoyed by it enough, I think, is more than enough to get you over the line, let's say, because you can learn everything else. Like that's all learnable skills, right? And I think that's the main point I'm trying to make.
Totally. If the problem is acute enough to you, whether you understand how to solve it or not, it's going to drive you to go find the solution one way or another.
Exactly. Yep.
Amazing. Okay, Ryan, let's wrap this up. Where can people find you? What do you want them to go look?
Yeah, well, you can take a look at my LinkedIn. That's probably where I'm most active. I can give you the link to pop up here, but it's, LinkedIn. I'm Ryan Melehan on LinkedIn. I'm also Ryan Melehan on Twitter. And then to look at Coco Alemana, you can go to Coco, which is COCO, Alemana, ALEMANA.com, and you can find my product there.
Awesome. Wonderful. Ryan, thanks so much. This was a really, really good talk. It was our first talk. It was our first podcast talk for the YouTube. I know, and it's all done. I like that. I'm sure there's stuff that we forgot, and maybe I'll throw it in the show notes later. But thanks so much, man, for coming on. And everyone else, thank you for watching and listening. I hope you have a great day.